We're going to get started here. So Maciek and Matt Reynolds here, they're going to be presenting some of the lessons we learned in our long journey. Well, it's feeling like a longer journey now in our microservices development. Matt Reynolds here is on our DevTools team. So building a lot of frameworks and tooling around microservice development. So service generators, Kubernetes, infrastructure, CI/CD pipelines, infrastructure pipelines, things like that. Maciek's actually on one of the teams that's really rebuilding some of the core guts here at Ibotta, which is giving people cash back for things that they purchase every day. So without further ado, Maciek and Matt.
All right, thanks, Scott. You want to just do the first one?
Oh boy, is it gonna work? Maybe.
Come on. Yeah, all right. So before we get started on the actual talk, I'd like to try and get a rough idea of the audience we have here. So if you could stick your hand up if you consider yourself a developer. All right, wow, almost all developers. I guess I'll go through the others. I was gonna say ops. Anybody from an ops? Okay, few ops, yeah, ops. What else? Management? Do we have any managers? Oh, we have a few managers. Okay. And QA? Any QA? Anybody else? Product project managers, that kind of thing? Data science. All right, cool. Woo. All right. So with that in mind, let's get started.
All right, so let's give some background for this talk. So for anybody who doesn't know what Ibotta is, it's a rewarded shopping app that is built here in Denver. In fact, sometimes in this very room where you're sitting. And the back end, which is most of what we're going to be talking about today, began life as a Ruby on Rails monolith built on AWS about 5, maybe even almost 6 years ago at this point. Started primarily by, he was here earlier, gone now, Justin Hart, our kind of main architect. So let's talk through our kind of base architecture. So obviously it's more complicated than what we're describing as quickly here, but it's most fundamental. The Ibotta backend is kind of comprised of 2 systems. One is receipt processing via OCR, that's optical character recognition, and a set of APIs that power our mobile experience. And so before we dive into this, I would like to use this delightful graphic that I found on Twitter, courtesy of @Benorama, whoever that is, but kind of the evolution of software architecture over the decades. So in the 90s and well before that, we had this very nice spaghetti-oriented architecture. Basically, you would start with a small project, you keep adding to it, and eventually it would be a mess. The little subtext here is AKA copy paste. Anytime you need a little bit of extra functionality, you grab it from one place and paste it over. It makes maintaining things a nightmare, makes tracking side effects a nightmare, makes documenting things really hard too. So at some point, we had this idea of, let's keep this pasta-themed metaphor, and let's go with a lasagna. But what do we mean by that? We still have this giant monolithic application, but let's try and split it out into layers. Let's try and keep abstractions. Let's make things a bit more dry, and maybe this will make our lives a little bit better. And that's kind of where we were at as an organization. So again, very simplified pictures, but this is kind of the basic architecture of data flowing into our system. Let's see if this works. It does, great. So as I said, everything is kind of more or less built on top of Rails, but so we have shoppers who take a receipt from wherever they've been shopping, and they take a picture with their mobile phone. So this then sends it into our nice big Ruby on Rails monolith. It flows through some kind of queuing system, goes through an OCR process, which takes the picture that was sent, turns it into data. Sometimes it's clean data, sometimes it's a bit more mangled. We got some nice improvements from people like Stephen Bayer here, who implemented nice fuzzy matching processors for us. But it flows through a bunch of different receipt processors and gets put into a MySQL database. Great. So then what happens when we want stuff to come out? Well, it kind of starts back over here in this MySQL database, and it goes through a various set of workers. Mostly what we're kind of doing here Let's not dive too deep into what these things actually mean, but we need to match things that are on these receipts with either offers or bonuses. Make sure, hey, this line of text doesn't match with an offer that we're currently giving you, doesn't match with a bonus that we're currently making available to you. If so, great. We pass this on to ledgers that we keep track of for customers, as well as producing notifications. It goes back out to your app, and happy people with money. That's what we like. We like making people happy with money. Real money, not Starbucks points, not any kind of intermediate system, but real cash. It's great. Okay, so that's simple, but then you run into all these different problems. How do you normalize data? Well, you start to have all these different per retailer processors that start getting more and more complex. Sometimes you take a step back and implement a nice common library that helps you do some of these things, but you still have all this logic that's kind of scattered throughout. And then you do something that's really, really bad. You start getting clever. You think, aha, I'm a very clever programmer, and I'm gonna make really cool assumptions, and it's gonna make this code pretty, and it's gonna make the process fast. So you start optimizing for specific paths. You start relying on data that you just happen to know is somewhere. Does anybody else know this is there? No. When somebody gets hired, do they know this is there? No. And so this doesn't really help. You start relying on global state, on tribal knowledge, and this is kind of starting to get more and more messy. I'm sure anybody that's worked at a startup in, I don't know, the last 15 years or so kind of is very familiar with this story. It happens everywhere. So our nice lasagna has managed to turn into spaghetti code again after all. And worse, there's now all sorts of hidden side effects, there's dependencies, and this becomes, yeah, it's just a nightmare to manage, to document, to let new people come in and work on it. Anytime you want to introduce a new feature that doesn't quite fit in with your old clever flow, things break. And that's not good.
All right, so coming to the idea for why do we need microservices? As we're growing as a company, we're gonna have like a growing customer base. That means also that we have a growing code base, and we're also got a growing developer base to service all of those other two. Because we've got more people, we've got more data, things need to be optimized for that. We need to change things around, we're making more features. So all of this gives us, there's just more things going on. So if we switch to using microservices, then we can start looking at building out and scaling those things independently. If we have our big monolith, every time like one little piece of it gets hot and needs to do a lot of work, we have to scale up the whole thing. Whereas with this, we can split those things off and have them run separately. It reduces that problem space for those individual developers. So instead of, as we were talking about, we've got this big whole thing and there's global state and there's like, I change one thing over here and that affects something else over there that I didn't even realize. Hopefully, if we build our service boundaries correctly, then we can have that sort of like a defined interface and we can change things underneath without having to affect the external customers of our service. And then also, hopefully, because of those kind of things, we can develop features faster because we're not reliant on everybody else. We can say like, we're changing out a little bit. It's not going to affect your external, or we're going to build a new piece on, but it's a new service. So until you're actually using it, you don't even care that it's there. So those are some of the kind of ideas and some of the thoughts that we were coming up against that we wanted to look at microservices for. All right, so the initial attempts, we started off, we're basically all in on AWS. If it's on AWS, we're going to use it. So we started off with Elastic Beanstalk and using because it had Docker and environment support for that. So that seemed like a good idea. And it's pretty easy to use. We could put some scripts together and make that work. Config changes were fairly easy. Auto scaling, same kind of idea as to what we were doing for like regular EC2 instances. So yeah, it follows. It's not too hard to use. But it's not that flexible. We can't really do blue-green deploys. We have to deploy in batches when we've got a larger scale. It takes a long time for things to come out. If we run into problems, then it's hard to tell what actually went under the covers and we end up rolling everything back. And then we can't do some of the things that we might do in a more advanced microservice structure where we sort of have little things that get it added to you, like the X-ray tracing and things like that. If we want something, then we end up, instead of producing like a nice small Docker image that just has our code, we have to roll everything all in together, and it's a big ball and it just goes in there. So it's kind of problematic in some ways. All right.
Okay, so we realize that our monolith is maybe not going to live with us for all that long. So let's try to have our nice, lovely ravioli. I feel like we maybe missed a couple slides here, but anyhow, let's just go on. The bottom of that image is the new architecture that we're trying to get to, which is ravioli. And the idea being is that you have all of your services that are kind of, nicely and neatly packaged together, and they're bound together with some nice sauce. Great. But then there's this never ends up being quite the easiest process as maybe some make it out to be. A disclaimer here, as everybody who works with me knows, I'm very opinionated. These are my own personal opinions. But I think there are just some ground truths that you have to accept when you're doing a monolith to microservices do-over. This is going to be a long, difficult process. Just taking something from monolith to microservices doesn't immediately solve all the problems you have. And depending on how big and convoluted your monolith is, this is going to be a challenging task. This is going to take a long time. It's going to take a lot of investment. And during that time, you're not going to be churning out features. And this is definitely something that I feel is missed in some microservices talks. You have to take that time to invest into your architecture, into your developers, into your tooling. And it's all about amortized costs, right? Like if you take this time up front, later on, you end up with a system, hopefully, that's more stable, more manageable, more scalable. And so it's all for the good, but you have to be willing to pay that cost as you're actually doing it. Great, so like I mentioned, you've decided to go service-oriented architecture. Great, all your problems are done. No, just kidding. There's a lot of stuff that you have to agree on as an organization before you ever even begin to write your first line of code. You have to agree almost on a contractual level, what are going to be your transport layers? And you don't have to decide on one, but you have to agree on this as an organization and see what works best for you. Do you want to use HTTP or REST calls? Do you want to use gRPC? What kind of things are you going to be using to shuttle information back and forth when it's not immediate calls, when you have to have some kind of asynchronous processes going? Are you going to use SQS? Are you going to use some kind of MQ product? There's no right answer for any of these questions, but you have to take a look at what's out there, see how it fits into your current infrastructure, and see how it fits into your needs, and you have to agree on something. And this has to be something that's done at a relatively high level. It doesn't mean that your CTO has to come and decree, we're going to be using this, but you have to have all of your stakeholders, you have to have representatives from all your teams or squads or whatever you're calling it that's fashionable these days. You have to have everybody come together and say, yes, this is going to work for us, and figure out that that's good. Kind of going forward with that, agreeing on message format. JSON's falling a little bit out of favor these days. There's nothing inherently wrong with it. Maybe that's okay for you. Maybe you want to explore something.
I like JSON.
All right, there you go. You're wrong. That's okay. Maybe you want to use something more binary and formal, like a proto or an avro. Again, there's not necessarily a right answer to this, but you have to come to some kind of conclusion and stick with it. You have to ask yourself a question: what does backwards compatibility even mean? So one pitfall that we've had. So we decided to use mostly protobufs, even in some occasions where we're passing protobuf information as JSONs. And when people talk about protobuf, they say, oh, it's great. You can have this kind of versioning thing. It's backwards compatible. But then it turns out there's nothing inherent to protobuf that makes it backwards compatible. You can make breaking changes anytime you want. Your system will break, but that's okay. Protobuf doesn't prevent you from doing that. So you have to enforce a lot of organizational kind of rigor and standards and practices around this. And obviously it doesn't apply just to protobuf, it applies to anything. So you have to figure out how your system, and not just your system, but the communication evolves over the life cycle, right? You're completely redesigning the whole system. You have to think about not just how I'm gonna do it now, but how the system is gonna continue to live and evolve. Because if systems didn't evolve, we wouldn't have jobs. And then also, almost related to backwards compatibility, how do you manage your inter-service dependencies? How do you set up contracts between these services, right? We always say, Like an API is a contract. Great, that's a nice thing to say, but again, in and of itself, it's kind of a meaningless statement. So you have to figure out when we do deploys, how do we make sure that if two services depend on one another, deploying them in the wrong order doesn't break things. Or if it does, we have to have something in place that makes sure it's not going to break, and we're never going to enter that situation. One really nice kind of analogy that I've heard at some of these talks is the big fundamental design shift that you're encountering when you go from monolith to microservices is you're trading function calls for network calls, right? And this is something that you have to think about not only in the encapsulation of your logic, but as you're reasoning through your program, you now also have to think about, hey, I know that function calls aren't free, and so I maybe don't want to make tons of them because it takes time, but network calls are even more expensive. And that's something that you have to kind of keep in mind, as well as, function calls can sometimes fail, but maybe not that often. Network, as we all know, can be very unreliable. So you have to bake in a lot more assumptions around these new boundaries that you're creating in your programs. And also, as you're encapsulating all these pieces, because they're in separate components, observability and metrics become a lot more important. And so kind of a personal observation of mine that I've noticed as I've been going to a lot of these monolith to microservices talks is that microservices or SOA or whatever you want to call it, however you want to design it, work because of two things. The secret sauce of tooling, which is I feel something that's often skipped in these talks, and excellent monitoring and metrics. And so kind of an example of that, I went to a actually pretty excellent talk at AWS reInvent last year, where the BBC was talking about how they've gone all the way down to nanoservices, because microservices weren't cool enough. But the idea was kind of like that each of these orange boxed regions on their webpage is served by an individual nanoservice. That's pretty cool. That's very, composable, it's scalable. And they gave this nice architecture diagram and said, we're going to tell you about all of it. And they were talking about how they're using Redis for caching and how they're using queuing and how they have this whole, everything is stored in S3 and it's easy to upload. And then they skip over the platform itself. And this is interesting because I feel like this is really, really that special sauce, the nice thing that holds the ravioli together. And this is something that, at least as far as I know, nobody's figured out how to commercialize, how to standardize. And so every company that goes microservices, whether it's from scratch or whether it's transitioned from a monolith, this is what actually makes it work.
All right, so now we're going to talk about building that platform. And I'm going to come and stand on the other side of this, just for a change. And so starting out, basically we use Kubernetes to deploy all of our services on. And we use kops to basically deploy that. That's like a AWS specific kind of Kubernetes deployment setup. And Terraform, because you can't just do it with kops. You need some kind of infrastructure provisioning as well to create that cluster for us. We built like a staging and a production cluster. And when we built it as staging, we meant it to be staging for our team, but it kind of like the name generally became a staging environment for everybody. So I wish we'd have called it like a sandbox, because we really intend not to build a whole kind of a whole new staging environment of all the possible services that could be there. Because that's generally kind of like a monolith thing. If you set up you have your main production and then you set up a staging environment and you test in staging and everything should be the same. And it never really is. Staging is just a very expensive version of works on my machine, as far as I'm concerned. So never mind. Next time we'll call it sandbox, but that's what we did. So we experiment and we upgrade on staging first. And that also helps us chaos test our services that are running on it by occasionally taking things down. But we use basically some of that Kubernetes capabilities, daemon sets for our log aggregation and metrics. So that's how we can suck out all of the logging data, all of these services right to standard out. It all gets absorbed through that and sends out to sumo logic in our case. And then for metrics, we have statsd and Datadog. So we can pull out all of the data from that And that does a really nice job of giving us a lot of tags so we can sort of view things and see like what service it was, what pod, what machine, all those various things. And then because we're running on AWS and we have to care about IAM or the permissions and roles, rights, like to be able to access things. There isn't a native solution for that right now on AWS. I know that they're working on it. I mean, if you read through the tea leaves and look in the right repos and documents and whatever, you can see that there's an effort to do that. And I really hope they get that done because it's kind of painful. We started with a service called Cube2IAM that was basically, it traps the calls to get roles and responsibilities and does that for you. So you can just parameterize and say through an attribute on your pod, say, hey, I need this role, and it'll go do that for you. And we switched to using this other service called KIAM, which uses a similar kind of approach, but instead of having every pod, sort of everyone do it, it has some servers which go grab the roles and cache them, and then the actual pods can get them. So it has less issues when there's a big rush of sudden new pods come online. So that's a useful tip if you're looking at that kind of thing. And then we run the Kubernetes dashboard. That's a pretty nice UI for devs to be able to get hold of. It gives them, they can see like what they've got provisioned. They can look at the logs, they can exec into that and do those various things pretty easily without installing any tools. But the important point to note is that it has a minimal role and service account. So we use an RBAC and we use a service account token for the developers to log into that. Because if you don't do that, like Tesla, then somebody may find your dashboard and run Bitcoin mining on it, which is probably pretty expensive. Okay, so then in terms of how do we get those services onto the cluster, we use a cool tool called Helm, which pretty much everybody considers like a package manager for Kubernetes. And that's basically you have package all your resource YAML into charts. So you can specify a bunch, instead of having like an individual thing of saying like I have a service and I have a pod and I have this, you package all of those together in one deployment object. And it has template support. So we basically do have these templated charts for a regular service and for a cron service. So developers don't need to worry about all the Kubernetes YAML. They set up values, just like a little values YAML in their repo. And that's basically says all the things that they need to do about their service. Like, hey, I want this image and I want this number of pods and it's going to have this endpoint, these readiness probes, this auto scaling, all those various things. A lot of them can be optional. There's only a few that are core to it. And then we sort of put in basic, reasonable defaults, but they can change those as they want. And so that's how they basically get those in. And we started off wrapping these Helm commands with scripts so that we could do things like blue, green deploys and that kind of thing. But now we've moved to a service called Harness.io, which does the deployment for us. So that basically allows us to have it has a nice UI. It's much better than like a little command line script. It does some intelligent watching after the deploy has taken place. It can look at the logs and metrics and use some machine learning to say, hey, this is generating way more logs, or there's some errors or metrics are way different to the last deploy, and automatically roll it back for you if needs be. No, we're just running straight. So we use a COPS cluster. We have done some experimenting with EKS, but it's not quite there yet. They've only recently had the ability to do horizontal pod autoscalers, which is pretty important to be able to scale up that pod against traffic. And there's a few other pieces that still kind of like we're waiting on. I would expect with reInvent coming up that we'll probably see some more stuff around capabilities on EKS. It's definitely a lot closer than it was when they first launched it. So I would say if you're starting to look at Kubernetes on AWS now, then EKS is definitely worth a look, and probably by the end of the year or early next year, it would be a more solid kind of version.
Fingers crossed.
Yeah, it can only get better, right? So now onto a service mesh. So I was a big fan, like when Istio first came out, I was like, yeah, this is awesome. It's going to do all these cool things for us. And we don't have to have the developers worry about it. Just have this little sidecar. It'll trap all the traffic and route it. We can do fancy routing. We can do security. We'll get all our login and metrics. And that seemed really promising. So we started out with that and we ran it on a little staging cluster and everything seemed fine. And we started running it in production and when we didn't have too much traffic and everything was okay then. And then we started running more services and more load and things started to go horribly wrong. So we built some tooling out with it to be able to have this, like the canary header and percentage traffic switch, which was really nice. But the pilot part of it, which was the part that we're supposed to sort of figure out all the routes and send that off to the individual sidecars, just was failing badly for us. We tried upgrading, we tried various things, but it just wasn't really working and it was starting to really affect the services that we were having running and they were becoming more important. So in the end, we had to rip it out and that was kind of painful at the time.
Yeah, ironically, our bit that provides resiliency wasn't resilient.
So now we run Nginx ingress controllers, and that's how we get our ingress into the cluster. We have like a canary capability effectively by having two different services. So we have, and those we switch on labels so that when you promote, you switch from the canary service to the main line. And the canary is basically like an internal API endpoint. So you can hit that, but no, the main traffic still going to the other services until you switch.
Yeah, one interesting, I don't know if pitfall is necessarily the right problem, but interesting challenge that we're dealing with relating to canarying is even with the Nginx controllers and just having switching of labels, it's relatively easy to figure out the routing for your services that are coming, or your communication that's coming into your service. So basically any kind of internet call, let's call it, whether it's HTTP or gRPC or anything else, like, right, we know how to route those things. The problem that we're kind of facing, that we're facing currently is how do you do this with pulled resources? So for example, if you have two pods that are up and they're both supposed to be reading from an SQSQ, how do you know, okay, this one is supposed to be dark right now. This is supposed to be the canary one. It should not be pulling from the resource, or alternatively, it should be getting kind of ghosted copies of messages from that resource. And as we've been looking around, it feels like a problem that a lot of people may be dealing with, but we haven't found and seen any great solutions and are still trying to kind of architect our way around this.
So we were playing with it about like 0.7, 0.8 when we were seeing a lot of the pilot issues. I know that since they went to 1.0 and 1.01, things are supposed to be better. So I definitely I would like to go back to it. I definitely wouldn't say like it's a really bad idea, don't do it. I think the idea is great. I think it just got kind of like ahead of itself. I'm somewhat disappointed that they basically completely rewrote everything. They changed all of their setup as how they were doing it. So there's a whole new set of APIs and whatever for it now. So that makes life a little more difficult. And also because we're what we've seen with Nginx, it's been so much more solid and it handles everything without like minimal load. We're not ready to go back yet. I think there's more. I'm really interested in some of the work that they've been doing about security and authentication and some of the OAuth and JWT pieces. If you could pull that out of services as well, I think that's a really nice piece to be able to have. So it's something that I think we'll evaluate again in the future and see kind of like when's the right time for us to go back. All right, so basically in terms of when we're having all of these developers building all of these services, there's a lot more things going on and it's a lot harder to keep track of. So as I put there, we really need to help developers become more self-sufficient. We need to be more self-service. We need to help them to be able to be more empowered and do the things that they need to do without just writing tickets for everything. So the idea that we have for this is we call it paving the road to production. So paving the road to production with tools. And this also helps us in other subtle ways as well, because when you go to microservices, theoretically, it's like, hey, if you can get it in a Docker container, I can run it for you. But there's some downsides to that, where if everybody uses I've got one team over here writing Rust, another one doing Erlang, somebody else doing some other thing, it makes it really difficult to support. It makes it difficult for, like, if you want to change teams or like people leave, it's hard to control that. So one of the ways that we try and kind of guide developers maybe is by having this idea of the paved road. It's like if you go on the paved road, it's pretty smooth, it's pretty easy to go. So if you're writing a Java Spring service or a Node service, like Kotlin's pretty close to Java, so yeah, go ahead. That's pretty straight and pretty easy. If you really need to do some other thing, and that's fine, there may be some weird data science kind of thing maybe that you want to write in R, or I don't know, something else. Yeah, sure. But you're going to have a harder time of it. You're going to be on the rumble strip. You're going to be off in the weeds. You might be out in the jungle, as far as we know. The less that we can help you with, the more you're going to have to figure out yourself. So that's kind of like, it also helps us to kind of try and keep things moving to an area that we can help control, but not limit people. Like if there's legitimate reasons, or if they really need to do it, and they understand, and we can help them understand the downsides to that, yeah, sure, you can still go ahead and do it.
Just because it's Colorado doesn't mean everyone wants to go off-roading.
All right, so starting new services. How do I start a new service? I want to get this off really quick. A lot of the time, there's a lot of boilerplate around. There's a lot of things you have to do. Create new projects, spin out all this stuff. So one of the things we use is Yeoman, and Yeoman is a node project that allows you to template pretty much anything. Doesn't care what it is. You can write a bunch of files and basically give it parameters that you're going to pass in. It'll give you a nice kind of question thing. So you say, what's the name of your service? What's your team? Blah, 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 blah. And it'll fill them all in, and whoop, there you go. Here's your service. So we have several of those. We have like for Java and Node. And we do like a little noddy skeleton service where you can call an endpoint and it'll give you something back. So theoretically, you could build all that up, test it, and see that it works before you start ripping all the bits that you don't want out and put in your nice stuff in. And so we also do things like the configuration of your CI. So we use Travis for that. So we can spec out a lot of your Travis file. We can do the Docker file, Docker Compose. If you're using local stack, we can do some of those for you. So it means that you can get going a lot faster on writing the business logic, all the points of the things that you're actually supposed to be doing, rather than all of the boilerplate and the other mess and nonsense you need to do. And so that values file that I mentioned earlier as well, that we give that you use to specify in Kubernetes, we generate that for you as well. So that's like a separate generator, and that gets roped in as well. So it says, okay, like I know your service is this, and like this is where the image is going to be, but you know, optional, what are these other things that you want to do? And then when it's generated, you can always go back, and it has comments in it about, like, you know, you didn't set one of these, but here's what, like, here are these values that you could set. So you can go mess with that after the fact as well.
And so again, this is kind of where that secret sauce is kind of keeping everything running together. Previously, if I wanted to start a new service, I'd have to figure out how it works in a given language, in a given framework. If I wanted to you know, have an ECR repository for this, I'd have to go submit a ticket to DevOps and then submit another one to get a database and then submit another one for whatever. Here, I run a Yeoman generator. I put some resource definition into our Terraform pipeline. They might give it a quick look over it. Hey, this PR looks great, and everybody's off and running. And then imagine, you know, scaling that process as your company scales, and it really just enables people to work quick. I don't think we've done any actual user testing on this, but getting a service up has gone from days to hours. And so this just really, really improves the process.
And it also helps when you're moving between teams, or you come and look at a different service, because they all look pretty similar, because they've all got the same heritage and they all like know the same thing. So it standardizes on some of those things. And it also allows you to do things on the basis of like, well, I set up this with this template, so I know that it has these tags or it has this information, and then I can use that in other tools. So I could use some of the tags that I set in there in part of the Datadog metrics to come out to say like, oh, this is owned by this team and whatever, things like that. So there's a lot of benefits to doing things like that. All right, so provisioning infrastructure. So again, like if we've got all of these developer teams and they're madly creating services, they're going to want things to go with them, like databases and queues and other such infrastructure. And if you've got a traditional operations team who have to do that for you, then that's a real pain, and it's a ticket hell, and you're waiting for it, and it's all super urgent, and they're like, I have 15 other tickets in my queue, and I hate creating databases, leave me alone. So nobody wants that. So in that idea of empowering these developers and allowing them to do the things they need to do, we use Terraform to provision our AWS resources, and we try and standardize that and help developers to be able to do that for themselves without having to write tickets or go tell somebody else that they need that, and then explain why they need that, and then explain, no, that isn't what I really needed, because like I didn't know that I needed to do that, and all the other things that go on through that interface between different teams. So the idea of those Terraform modules, that allows us to standardize some of the information so that we can, in the same way as like a function, you can give it some parameters and it'll create like a queue for you, and it'll create a dead letter queue, for instance, and just automatically produce those for you. And we also, yet again, use Yeoman here. So if you're doing a service, we pretty much know you're going to need an ECR registry to store the Docker image, and you're probably going to need a KMS key to decrypt secrets. So we have a standardized way of storing secrets. We use a tool called SOPs, which I forget. I think is it Mozilla? Somebody like that.
Yeah, I think it's Mozilla.
So we wrote a wrap around that, and that uses KMS keys basically. So it's a really nice way of working. So you can assume a role. You have access to that key. You can decrypt your config data or your whatever secrets you need. So we can help standardize that. We can give you, even if you don't need to do anything else, like you just started up a service, you don't know what you're doing, you can run that generator, it'll create some Terraform for you, and it's not too scary. And then we have a deployment pipeline process. So we run, like again, using Travis, and we can, so when you branch off that, you create your Terraform modules. When you check that in, it'll run like a Terraform validate and a plan, and it will kick out any errors that you have for that and make you fix them. And then when that's all done and we can review it and check that it's okay, then we can merge that into the mainline. And when we do that merge is the process that we actually do the apply. And so Terraform being Terraform, or basically any kind of language where you work with something like AWS, most of the time that works. There's obviously going to be issues where there's things that it doesn't know about when it hits the road of like actually saying AWS provision these things for me. Things might not work. So one of the things we've tried to do is bring an idea of what we call infrastructure specialists. So that's developers that are in the different groups and are interested in some of this. They have some interest in infrastructure, and they're more involved in it. And so we've tried to train them up more about it, and so that they can be a resource for their teams. They can maybe work more directly with us, so they can be a funnel point, take some of those initial issues, and then like solve some of the basic problems, do some of the PRs. And then if there's real like heavy duty problems, then they can bring it back to us and we can help fix them. And so, yeah, that's to say at the bottom, the developers write their own service modules, and they can, so like whatever like stuff they need, they build. So I have no idea like who's got what queue and whatever. Well, I could go find out, but off the top of my head, I don't know.
Yeah, I think one really nice thing about the infrastructure specialist is that it kind of embodies two things that become very important in this kind of DevOps lifecycle. One is democratization of knowledge, right? Like if you have a problem and it's relatively common, you don't need to go bug the core group of people who are working on these things. You have people that are closer to you that are, maybe have dealt with this more recently and can help you out. And then going the other direction, I think there's a lot of value in kind of dog fooding your own tools. But if you're, again, in kind of that core organizational structure, maybe you don't really have the time and the priority to go embed in like an engineering group and figure out, hey, how are my tools actually being used? Am I writing them for the right use cases? And so again, the infrastructure specialist kind of helps bridge the divide in both those directions.
All right, so next thing that we talk about is support libraries. So instead of having everybody use their own like loggers and metric libraries and things like that, we started off and built some base libraries for some of those things. So we have, like I said, there, logging metrics and security. And so that reduces that work for individual services. They can just pull that library in and use it, and they know it's going to do the things that they need to do. And if they're using our service generators, they probably already got them, even if they don't know. And that, again, promotes that standard approach. It makes it easier to upgrade because then we can use those standard libraries and just say, hey, pull in version 2.1 instead of whatever, and it fixes any of those bugs, that kind of stuff. Because we have that logging library, we now, everybody has structured logging. So we have like JSON formatted logs. So when you go and use a tool like Sumo and you want to do pathing and finding things in that, it's a lot easier because all of those logs have that same kind of format. And the same kind of thing for the metrics, we can add, like inject standard tags and give you more information. And then from that, we can build things like a standard dashboard. So we have a services dashboard, which is all of the Nginx pieces. And you can then go and sort of drill down by your service and see the stats. And then you can go use that basic template one to go build your own service specific dashboard. And the same for some of the work we've done around Java services. So if you're using Spring Boot Java, then it has a pretty nice metrics capability built into that. So we can then say, okay, we're automatically going to get those, and we'll add some information for you, and then build out a standard dashboard where you can see like the kind of things that you could get with it. Then go as a service team, go build the dashboards and the metric stuff that you want to see yourself. So the other nice thing about that is we run it as like an internal open source effectively. So all the development teams can submit PRs, and we're really happy to say that they have done that, especially on some of the node side, because we're not, within my team, we don't have a ton of experience on node for writing those services. So they've been able to go in there and say like, hey, this is an extra common thing that we need. Let's put it in that common services. There's also been some of the stuff around protobuf communications, basically, that they've been able to standardize for us as well. So this is another thing where we're leveraging we're not doing everything for them. They don't, it's not like they stand there and go, come on, I need this. They're capable of doing it themselves, and they can help build that out as well. So it's a real cooperation between teams. And it's building that kind of that DevOps philosophy. It's not really, you don't really have like a DevOps team per se. You want to have a DevOps kind of culture, and you want to have that idea of like where people can mix around and do those various pieces. And it's not like that's not my job is not really kind of a concern.
And so before going to the actual pitfalls and benefits, just to tie us all together, this is kind of our secret sauce, right? Like this is the culmination of many months of hard work by the DevOps team, by like a collaborative approach with all the teams as they're building services. We're making mistakes along the way, we're figuring things out, but this is what makes us work. This is what makes the engineering organization at Ibotta very successful, right? It's the fact that I can go and in a matter of hours create a service, and it's up and running, and it's up on a staging cluster, and then I could go mess with it. I can make it fall over, and it comes back. And if I have real problems, I have people to support. Or if I notice something new, I can make a PR against that. I'm not just chucking things over the wall and making sure that they come across. And maybe it's just the fact that every company is set up so very differently. Like your stack has almost combinatorial amounts of different variants it can have. And maybe that's why there isn't like a single nice approach to this, but it is something that is very important and is worth investing your time in, almost as probably even more so than just figuring out some of these other things that we were talking about, like HTTP or gRPC or whatever else. The tooling and the collaborative culture is really what makes this work.
All right, so there are some pitfalls to it. We've talked about more moving pieces. I mean, just in Kubernetes alone, you have like there's the Kubernetes cluster, but then I've got to worry about the network overlay. I've got my logging, I've got my metrics, I've got my IAM, got all these other pieces that are kind of like fundamental to services being able to run on it, and those all change all the time. And I have to try and figure out like when am I going to upgrade them, when am I going to change them. But it does give you a lot of capabilities as well. It takes time to build that platform on that tools. We were lucky in that we were able to start building some of this stuff before we really changed over. So we had those Elastic Beanstalk services, and we were able to keep going and do some stuff with that while we started ramping up this. So we could start off and build like an initial shared library setup. We could build out some of the figuring out like how do we get this Kubernetes cluster up, build some of this stuff, and build like an initial version of that service template without having developers going, is it ready yet? What do I need? Can I do this? I mean, even while we were building extra pieces like those, they could start building initial services and we could add stuff to it as we went along. It takes time to change mindsets and learn that new approach. I mean, I think you can't really emphasize that enough. It's a huge different way of doing things. When you're looking at services as opposed to sort of like when we talked about like that idea of the function calls to network calls, that's a huge deal. And you really have to think about resiliency. You need to start thinking about retries, what do I do, failover, circuit breakers, all of those. I mean, there's capabilities of things there to deal with it. But it's a big mind change, it's a big difference. And then just that idea of like, hey, you're going to have to write your own Terraform. You're going to have to deploy your own thing. That's kind of like, well, I'm a developer. I don't really want to do that kind of stuff. But it gives you that capability. It allows you to do the things that you need to do. And there's that trade-off and there's that capabilities. And also because of a limited kind of team like mine, we just say I have like 4 or 5 people. If we tried to provision all of this databases and queues and everything else, we'd just be a huge bottleneck and everybody would get really upset with us. You also need like that more explicit communication because like in a monolith, when you've got that shared database and it's just like, yeah, I can just put it in there, or I can just take that value. I don't need to tell anybody about that. Really, when you've got services and like, yeah, you've got that interface there, but you need to have an understanding of like, who are my clients, who's using this, what's the roles around it. You need to have more communication amongst those teams, I think. And sometimes that's something that I don't think people realize when they look at microservices. They go, oh, great, I can go off and do my own thing. I don't have to talk to anybody ever. It's not going to work as well. It's harder to test across services. There are things that you can do around that. I would generally advise against trying to build, as I already said, like a staging environment that has everything there, because if you're changing services all the time, it's never going to match. So there's things like contract testing. Pact is a good example of that, where you can basically write like in a DSL, like a statement of what you think should happen, and that will generate stubs and sort of service tests for you. And so each end can run tests against that and prove that, yeah, it does what we expect it to do. There's other kind of things that you can do as well around running small services together using Docker Compose or things like that, but trying to sort of standardize on your APIs, and that should certainly help. And then there's issues around long-term service ownership. It's like, okay, I built this service. You need to try and get away from this idea of features. Like, I'm going to set up a team to build a feature out, and then they're off and they're building the next feature. You want to build more around functionality and like having an ownership of something in a longer term. And so that team can stay in charge of those things. Because if you get orphan services and it's like, oh, who owns that? How do we fix it? That can definitely be a problem.
Yeah, and then, I mean, the pitfalls continue. One of the hard things, I think I mentioned this earlier, is kind of coordinating the dependencies across your deploys, but also coordinating that across independent work. Like when you're building a service, you have this nice, lovely idea of, hey, the network is my boundary, and people want to talk to me, can just deal with that. But it turns out that that's not really how engineering organizations work. You have to figure out who are your kind of stakeholders and what is happening both downstream and upstream of you, and make sure that there's a way for you to continue to facilitate that communication and make sure that you're not introducing breaking changes without even knowing about them. Yeah, ensuring that your events are general purpose and robust. I guess this is a little bit almost floating outside of the scope of microservices in general, but I think a lot of SOA architectures tend to be event driven. And so figuring out what are events and what makes them useful and long-lived, right? One of the problems that we saw in our monolithic architecture, and one of the motivating factors to move us across, is we had too much dependency across the organization on implementation details. What I mean by that is basically, you know, we take some data, stuff it in a database, and then say, hey, this database is open. Anybody who wants to use it, go ahead. So we'd have analytics, we'd have finance, we'd have all sorts of reporting being done across these databases. And then a couple months later, you have a developer come in and says, you know, I think we need to change this one column in this database for very good reason, but they have no idea who's relying on that information. And so you change it and you have breakage. And so you want to consolidate around, even if it isn't events, you want to consolidate around abstractions that are resilient and that are actually embodying business concepts, so that you have this way of communicating with the rest of your organization, be they technical or not. And under the covers, you can kind of change implementations as you like, but you need to make sure that you have that ability to provide a consistent interface.
Yeah, services need to own their data, and everybody needs to come in through the front door. They're mucking around in the back.
Yeah, and then the idea of kind of agile teams versus maintaining a high-level picture. When you're designing a system, especially when you're first starting to do this transition, you need to have somebody, or some buddies rather, come together and design the system with everybody in mind, right? Once your system is up and running, you can maybe have somebody go off and work on an individual service, and it's great because you know that the core system is there and the functionality is there. But if you start that way, then you have people running amok in all sorts of different directions, and you don't know how to consolidate, you don't know how to write integration tests, you don't know how to trace events to the system. So yeah, even organizationally, it's important to kind of maintain some level of coherence. I think Matt touched on this on a little bit, as well as team structure versus service ownership. Who maintains these services once they're quote unquote done? And one of the things that actually has been really helpful with that is a lot of these sidecars that provide you monitoring and kind of alerting almost out of the box. Because one of the things that you really need for a clean handoff is a maintainable project. And what that means is the code is clean, but also there's alerts set up, and you know what to do with those alerts. There are run books, and so kind of, you know, bringing this all together into a good flow and a good communication across your team is helpful there. But it can be hard, and if you do it wrong, you end up with problems along the way. That being said, it's not all bad.
Yay. So this, I think, is one of the key things. Teams are empowered to do what they need. So I put that as a benefit, but that's like a real cultural thing that you need to be thinking of in terms of, if your company is like a real command and control company and their boss has to say something and then it goes to the division head and then they finally get down to you to do the work, that's not going to work very well in a microservices environment. You really need to have like that high trust environment. You need to be saying like, hey, we got these people to do this job. We pay them. We should let them do it. And that's kind of the way that microservices can work, because then everybody gets to do their piece without having that high level of control. So that smaller services scaling independently and that lower blast radius. So if like I'm writing a service and I make some big mess of it and put it into production, like sucks to be me, but it doesn't hurt Maciek there. His service is just still going along fine. Whereas in the monolith, of course, everything is a big smoking crater. Kubernetes provides you a lot of resilience just off the bat. I mean, you can do liveness, readiness probes. It'll scale up and down. If machines disappear, it'll put them somewhere else. So you get a lot of real nice functionality for that just out of the box. So it's worth all of the setup as far as I'm concerned. It's easier to take risks and try new things. If you're going to start using some new language or platform or something else, you can write like a little toy service in it and try it out and try it on something like, hey, let's try it for something that people don't use very often, or it's some new thing that we're just trying out. And if it doesn't work, it's like, it's easy to rip out. It's just a small part of it. It's not like, oh, now we've got to try and pull this thing out of the big mess of our spaghetti. A lot harder to do. It's easier to work in those cross-functional teams because you have that service kind of mentality. And we've already talked about how we try and produce like that infrastructure specialists, but we also have like mobile developers working in a squad or in a team. We have analytics people getting involved in initiatives, things like that. And that's easy to do if we're working on sort of like a more contained problem space. That everybody's all working together on that area, as opposed to like when it's the big, huge monolith and everybody's doing all of it. It's harder you tend to work into those areas where it's like, I do the database, I do the front end, and have those separate teams. And then it's easier to align closer with other groups so that you can do that kind of thing, and you can also work more with the business because you have a more focused approach to them, and it's like we're doing this one thing, so we can help work with them and understand what's going on, as opposed to trying to do some big cross function, some big matrix kind of thing where I'm on the platform team, but I'm on this project and I work with that PM and this business owner.
Yeah, and then, I mean, one of the things that's always touted about microservices, and ends up being true, is that they do take kind of a Unix philosophy to these things. Do one thing, more or less, and do it well. You no longer have this need to, whatever framework you decide to create your application in, it no longer needs to do everything, right? Like you can pick and choose kind of the best tool for the job, whether that's a framework, whether that's a library, whether that's a language. You don't have to shoehorn everything that your application could possibly ever do into that one place. That being said, one of the nice things is if you're kind of using this, what we've been calling the paved road analogy, it kind of makes you think about like, okay, we have a common set of tools that most people are using. Is there a great reason to stray from this? Sometimes there is, but this also keeps you from situations like you read about at, I believe it was Uber. They have thousands of microservices that are written in God knows how many languages. That becomes really hard to maintain. As a developer, it can become really hard to move across because now you have to learn either a new framework or a new language all the time. If all of your Rust developers leave, what do you do with that service? And so it's good to keep that balance of right tool for the right job, but not going way overboard with it. It provides a lot of isolation and also encapsulation of your business logic, right? So now we don't have these weird interdependencies that are weaving their way through the code. You're not relying on global state because there's no such thing as global state anymore, right? Like the other function lives in a different pod, lives on probably a different server, and you have to make things a lot more explicit. It's almost a functional approach to writing systems. You have to make sure that things get encapsulated well. And this keeps the business logic clean. It makes things more composable. It makes things more maintainable. If you want to upgrade one single part of your system, chances are you can do that. You don't have to worry about like, okay, but now that touched that one bit over in the database and the other system was relying on it. It's a lot kind of cleaner. And I put this in scare quotes because of some of our earlier experiences, but you have easy canarying and testing of individual components.
Yeah, so that all goes to that idea of kind of like testing in production. Can I sort of put this in dark? Can I send a certain amount of traffic to it? Can I do synthetic transactions or things like that to help me figure out what's really going on? How is this really working? As opposed to kind of like it works on some artificial environment.
Yeah, because as much as like we pretend otherwise, nothing is like production except for production. Wouldn't be a Meetup talk without a plug. We are hiring. If you're interested, let HR know that we referred you.
So yeah, I mean, generally if you are, there's plenty of people around with Ibotta shirts on, or you can come talk to us and we'd be more than happy to talk to you about it.
Any questions? Let's see if we have another mic to pass around.
Yes.
you're breaking your monolith into microservices. And so what used to be a function call to another part of your monolith is now a service to service call to some other service. I'm skipping over the part where you decide what the boundaries of the services are and saying, all right, how do you build in resiliency to that service to service call? So you say, if a particular instance of service B fails, well, I trust Kubernetes to spin another one up and route my call to one that's actually running or something. But if I've deployed a bug to service B so that whatever node I go to, my call fails, does that mean that everything depending on that suddenly fails also? Or how do you build failure into that?
Yeah, good question. So in terms of resiliency and like if I've got a failure in a downstream service, how do I deal with that? I would say like one thing that I could do is like if I do a canary, so I only change like say one of my pods, so 10% of the traffic gets the bad thing and I see it, it's horrible. I go, oh, it's a horrible mistake, quick, turn it back. So I've lost some, but hopefully not everything. And then there's the pattern, like a circuit breaker pattern. Like Hystrix is a good example of this for Java, where you can say like, hey, this is it's like a command function. And you say, this is my command. If there's a failure, do this thing instead. So that is dependent on what that failure type is. So if I get like if it returns me a 404 or some other kind of message like that, then I can say like, hey, do this thing, like send a cached result back, or send them like, when I used to work at another company, we would say like, if we didn't get the price, we could say, see price in cart, something like that, whatever, sort of like, and hope by the time they get through to that, then we can, it's responding and it's working properly. So depending on the situation, but I think that's a real important point that you have to have that discussion when you're building your service and you're talking to your business owners about like, hey, what do I do? Like if I'm trying to get the price, what do I do if I can't get it? Is it okay if I give them a stale price? Okay, how long is it okay for me to give them that stale price? Is it an hour? Is it a day? Whatever. If I can't get that, if my cash has gone out or I've done something else, what do I do then? And have those conversations about it. And I found that can be pretty scary at first because like, especially on a business owner, they're like, but what do you mean it could fail? Why am I paying you this money to build this thing if it's going to fail? But once you kind of show them like, yeah, remember that thing that went horribly wrong last year when we did Black Friday and it all tanked, then what do we want to do? We don't want that to happen. So like, what can we do? And they'll start to get into it and they'll start to say, okay, yeah, well, you can give them this, but for only like an hour or two, because then we get into trouble if the price is too stale or whatever. And okay, maybe we can't give them a price, but we can do that sort of like go check it in the, when we do a checkout, because it's a different thing and we run in tax and everything else. So that's a different service or whatever other the kind of things that you want to do. So it's that trying to get to that idea of it's not all or nothing. It's not like I give you absolutely everything or I give you nothing. It's like, I kind of got the picture and a bit of a description and some other stuff. Is that any use? Should I give you that or should I just do something else? So that's all that kind of capability is something that you can do with that microservice approach, as opposed to, like we said, there's a monolith and you rolled something out and everything's getting done and the database is getting underneath everything, or you've crashed the whole thing. You're in a horrible state. So you can do with that microservices, you can potentially do a degraded result and you can give them some of the stuff and they might not even notice. Like there's a lot of examples of Netflix where they show you like, oh, I couldn't do the personalized view, so I gave you an alphabetic thing, or I gave you the generic view, and things like that. So I think that's the approach that I would talk about for resilience. Yes. Mike, coming behind you.
Oh, hi. Just wondering, how do you guys handle versioning of your service? So you have, a base initial version 1 that went out. Hey, developers say, I got cool version 1.5, right? And then business say, hey, I want more, right? Version 2. So deprecation of your version 1, you can't say, hey, tomorrow version 1 shut down, right? You give them some time.
Yeah. Like so yes, I mean, there's kind of like internal services and external services in terms of like the services that we use that we rely on internally for like our Kubernetes cluster, things like that. That's something that we would, we'd have to go look at, try out, and do that. For internal service, one thing that we do is like never make breaking changes. Like we don't really want to go to Semver, like, we don't want to go a whole version. Like if we're going to do Semver, we really don't want to go from 1 to 2. We're always trying to make backwards compatible things. So think about what you're doing. Don't change the name of it just because you thought of a stupid name to begin with. You're going to have to live with that now for the rest of your days. A version like in the URL. Maciek, what do you do? I don't know. I mean, you tell 'em.
I mean, as much as possible, we don't actually use versions. We rely on the principle of don't break things. On the off chance that we do introduce breaking changes, we may end up doing just a very high level version like V1 versus V2, not relying on the underlying Semver beyond that. But really, we're kind of still exploring the system design right now. The internal services are kind of meant to live very close together, both in terms of the services themselves as well as communication between developers, and having some kind of sandbox environment really helps with that.
So, I mean, the other thing is like, yeah, if you have to do something, then it's kind of like you have to do the addition first. So you have to say like, hey, I've got my old version of thing, I've got a new version of thing, and I take that and I plug in the old and the new, and then I kind of like eventually depreciate the old. So that's basically the end result of how you can do it. Like especially when you're talking like a backend database and you've changed stuff on that, you have to do that migration and you have to do that kind of like painful kind of process. So that's why we try and aim for like, don't, make the effort first when to design it properly in the beginning, but know that there are going to be some changes, but make those changes as like additions and not as like, oh, I'm going to rip this thing out now, or I'm going to rename it and restructure it. It's like this.
Yeah, honestly, kind of the hardest part where we have to deal with that is effectively our one external consumer is mobile applications. And so you have to figure out how to deploy changes to mobile apps such that, as little as possible do you push a required update to people, because you can't always count on that and you don't want a tons of people's stuff to break. So we often end up in a situation where you're kind of using both the old and the new thing at the same time, and watching, the old version of the app kind of trickle down. Or for certain content that we're serving to application, we can kind of gate that too. So one of the headers that we get back from the application is app versions. And so we can kind of know like, hey, if you're not on a new enough version, we're not even going to serve you this certain style of content or this new information that your app would never know how to render. And so that because we don't have any control of people's phones, that's a lot harder. Like there's still hard breaking changes to deal with internally, but those end up not being nearly as complicated as the external ones.
Yeah, and we also use GraphQL some for that side of things. So that allows you a little more flexibility, and then you can do kind of more querying and less rigid. Like this is the format that it's going to be.
So for like internal service to service stuff, it's part of the reason why we chose gRPC and protocol buffers for actually defining the contracts between services. Because then if that contract changes, technically you'd have like a compiler error within client services that are trying to use that. And so that's an indication that, hey, I can't make this change yet. Someone's dependent on this older version. So having a sort of a contract system, which gRPC allows for, really helps with stuff like that.
Yeah, and our gRPC releases, those are pretty tightly versioned. And so those you have to like, we're kind of figuring out exactly how to build it out, but that's kind of our contract for the moment.
Yeah, and so to what Matt was saying, you'd add the new endpoint of, hey, this is how I plan on serving this data in the future. All the clients need to then migrate to that. And then once no clients are using the old interface, then you can actually deprecate it and remove it. So once you get into a distributed system, you have to be very cognizant of how you upgrade, because you have to allow time for clients to upgrade. Just like, PayPal, I don't know, 6 months ago or something said, hey, we're deprecating this API and you got to be on it by September, whatever. Did we hit that deadline by the end of September? you got to, be off the old API because we're turning it off. And so internally, that's obviously a little bit more flexible because you have control of both clients and servers. But it's sort of the same concept. I think that's one of the important things in microservices is thinking of everything as a public API and treating it that way where, hey, if you want to change something, like you're going to either break your clients, which most APIs don't like doing, or you need to tell them that you're going to make a change and then give them the time to make that upgrade.
Is big. So there's a lot of client, right? And then you have client 1, 2, whatever that has no more money to upgrade. Now you as a service provider is now kind of held hostage, right? To client 1, 2, because you can't shut off your version 1 because you're now in version 10. You're keeping 10 versions around. And you can't maintain all those.
How much money are you making from those old people on version 1? If they're too tight to upgrade, are you making enough money, or could you just say, "I'm sorry, like we're not using you anymore"?
It's not a money issue. It's more of a upper management. I mean, I got these cards. Don't break it.
Okay. Well, like I said, we are hiring, so.
Yes, I know.
I'm sorry.
So do you care? So as you're building more services and more people are doing sort of things on their own, do you care that that the engineers still have a mental model of how the whole system works? And if so, like, what do you do to keep that mental model going?
That's a fantastic question.
It is. I think it is important, and I think it's in terms of like at what level. I mean, obviously you don't need to know the guts of every other service, but I think it is useful to understand and know what at least at a high level, what are the other things going on. And so we do things like lunch and learns, and we have kind of like there's in between groups sort of teaching out around that and all the other documentation. So I think we try and do that. That's probably something that we could do better and that we should do better. But yeah, I think people should, at least know roughly what's going on outside of their little world.
Yeah, one thing that we've been really trying to do is kind of keep our documentation hierarchical, right? So we want to have one clear picture of the system at large. And so far, our kind of most successful approach at this has been kind of a data flow or actor model, right? You have your consumer on one end, and you see their inputs. You see them flow through black box-ish diagrams, but more or less like, hey, this is the service that deals with, things that are coming in from the consumer, and it passes on to a couple of other large services, even if those are then comprised of multiple, like maybe even dozens of microservices in there. And then, if you're interested in a specific part of it, you can drill down, right? Because keeping a whole mental model of the architecture is at some point becomes impossible, and not even more than impossible, it's not really helpful, right? Like you need to know the major building blocks, and then if you want to dive down into that, you can kind of see what's going on. And if you need to debug a part of it, there's rarely ever occasion when you really need every single microservice that's along the way, because half of them aren't even going to be dealing with that information. So as long as if you have a way to cobble the large events that are flowing through and see where things end up or where they might not be, I think that ends up kind of being most helpful. But as with any kind of organization, documentation is always a battle of keeping it up to date, of keeping it relevant enough, of keeping it useful, depending on what situation you're kind of using it in.
I had a question about databases, and since everything is going microservices, do you recommend having, we still want every service to have its own database if we are truly microservice, that is, but in reality, sometimes it's not even possible. So there's a shared database, which 2 or 3 services are accessing, and then there's a lot of problems where the services are scaling, but the database is not. So how are you guys fixing the problem? Do you have different databases, shared databases?
Yeah, we have different databases for those kind of problems. Yeah, and also once you have something shared, there's that real strong temptation to just like, oh, just stick it in the database, put a flag on it. Everybody will know what that means, and before you know it, you've gone back to like a monolith. Yeah, that's what I wanted. One of those. So yeah, we try and stay to like we can spin up RDS instances all day.
Yeah, and kind of the way you can solve, I feel like a lot of those sort of, hey, I need data from all these different places at once so I can do something. It tends to be an analytics concern. And so that's where a data lake comes in. Like we can have services all day that have independent databases for operations, but we're still producing events down into a data lake. And then analytics can kind of have that combination of events from all services all at once and not even really care about the service infrastructure, which has its own risks, but has value too.
Yeah. So I'm wondering about your, you use the Terraform and like you spin up a new service and I take it then part of that is that the dev teams have to own the infrastructure, at least script it out. How much automation is behind that? Terraform is a great tool because it maintains your remote state. And so it knows the state of what's on AWS. It's also really scary because it knows the remote state and that might be out of sync with reality.
Yeah. So that's why we say like everything has to be done through Terraform. We have like our original account, which is like, it's monsters and the rest of it because it was all hand jammed and everybody did their own thing. And so like we split off from that and said like all the monolith and the other things are in there. But like for this brand new world that we're building with microservices, it's all going to be Terraform. And so that Terraform pipeline that we talked about, that's how we manage we have that one state and we manage through that. That's starting to become a bit of an issue because it's because of that pipeline. Every change has to wait in a queue. And if somebody breaks on an apply, then you have to swarm around that and fix it. So we are looking to splitting out into sort of smaller, different sort of Terraform modules for different areas. To try and get around some of that problem, but trying to do some of those automation things so that developers don't have to be experts at it. They can use like some of these modules, they can use like Yeoman generators, things like that. And that we have the support for them with people who within the team and within that area that have that, but they can also come back to like more specialists on our team to say like, hey, I'm trying to do this really strange thing, or I've got this we're going to use SageMaker or some other thing that we've never used before. Whew, yeah, cool. How do we do that? And we'll go, I'll find out.
Yeah, to kind of
Google
emphasize
SageMaker.
To kind of emphasize one of the points that Matt made is this is like a single pipeline that's running via CI/CD. So no developer is ever actually running applies from their own personal machine. There's one thing that can run at a time. There's a lock file, and that state file better be up to date all the time.
So how much trust do you have in that, though? I mean, is it a two-stage? Is it one-step process, commit and go, or is it two-stage plan? And
yeah, it's a two-stage. So you branch off, and when you commit to your branch, then it does like a validate and a plan, and it will kick out errors on that. And then when that's all done and it's gotten like, it has to be like, we have the GitHub thing. So it says has to be approved by like, 2 people. They check it off and say, no, that looks all right to me. And then we do the merge in, and then that does this, it does the same, does the plan again, then does the apply. And if there's, the build will break, if the apply goes wrong, and then we have to go fix it, or like, the state file's locked or whatever. So yeah, there's actually a project, I want to say Atlantis, maybe Apollo. Yeah,
I've seen it.
Yeah, that's kind of like, that's something that we looked at after we'd already built this stuff and said, oh, that's kind of nice. So I think if that's something you're contemplating, I'd definitely say take a look at that.
Okay, thanks.
The other thing that helps is we have our own kind of configurable rails on it. For example, I forget what the exact number is, but if your plan ever tries to delete more than X amount of resources, it automatically fails unless you go in and manually kind of reset that limit, right? Because if somehow you accidentally committed, delete all my resources, you don't want that to ever go through.
Yeah, that's a good point.
I'll just add, you call them monsters, I call them the good old days.
sorry if this was brought up or answered earlier. You can skip it, but I was curious about how you went about the process of breaking apart the monolith. So for a little bit of context, we've gone through that, I've got good experience with the team going through lots of thinking about bounded context in the domain. And then specifically how that applies to the team, like you talked about long-term service ownership. I think everybody on the team's generally okay with having not the whole mental model themselves. We've outgrown that, the ability for that, using events, and largely have prepared ourselves pretty well to start breaking apart the monolith. But then when thinking about, okay, we've got the companies in the fitness space, so workouts and athletes and coaches, and then subscriptions and products like emails and whatever, a lot of very different things, which could lead to dozens of services, but more services than team members. So how did you go about that? And did you try and aggregate some things, or did you grow the team to accommodate those things, or what did that look like?
We did it well. Next question. No. So
viciously well.
One of the things that kind of complicated our transition is not only were we going from monolith to microservices, but we're also taking this fundamental design shift from these very open and accessible, basically database records, to these kind of more abstract business concepts. But the approach that we really kind of tried to take, and I forget who originally coined the term, but it's called the strangler pattern, where you kind of you try to already abstract the functions of your monolith and take those out piece by piece. And this gives you a lot of nice things. For one thing, it means that you don't have to immediately build the whole architecture from scratch, right? You can take out one piece, build a microservice, and kind of shim it back in, make sure that it's working. This also means that you never have, or not nearly to the same extent, you don't have a, hey, we're going to turn off the old service, like the old monolith, and turn on the SOA. You don't have that, oh shit, what's going to happen to my company moment. But that being said, because this, the monolith is kind of existing in this spaghetti state, there's definitely moments when that becomes hard, right? And you have to kind of just weigh your priorities, weigh your where you want to be on your roadmap at any given point, to say, okay, in order to really abstract this one whole feature out, I would need to make 3 or 4 microservices. Or I can take this one bit, take it out, and add some little extra shims in, and kind of make it, if you squint, look like the old model, so that it's kind of flowing back in. But it really, really becomes a case-by-case basis. And then in terms of allocating resources, it kind of makes it easier, right? Because you're only doing a couple things at a time. And so you don't have to be able to have the manpower to staff the whole architecture at any given moment. And even better, if you have certain, units of people, whatever you want to call it, working on multiple of these microservices, just inherently they start getting a reasonable idea of how the system works, how the system flows.
I think also you have to worry about that return on investment. I mean, just because it is a monolith doesn't mean to say you have to kill the whole thing. I mean, there's probably going to be the rump of monolith is going to be around for quite a while. I mean, there's core things that it does, and it does them well, and they haven't changed. And if you go look at the code, you have to blow the dust off it because it hasn't been changed in a while. And if it's solid and it works and it does what it needs to do, then it's not a priority to go bust it out just because it's Ruby on Rails. So I think you pick the areas that are going to give you the biggest impact, and also look at when you're building out new functionality, that's where you can start. So if you're really starting off in a microservice, maybe build a little new service and have that as a facade that goes and does talks to the old monolith and does things separately, and kind of cut your teeth on that rather than try breaking up your working system.
Yeah, kind of to that point, I think that's why I like the term SOA more than microservices, because quite frankly, I don't think we're ever going to be completely rid of our monolith, and there's nothing wrong with that, right? It will just always do certain things well. There's a reason people use Ruby on Rails. It's very good at some things, and if you don't have to get rid of it, one of the motivations for going to this is you're hitting scaling issues. But you have something that the core bit of your monolith does well, and it's going to keep doing well, keep it around.
That, Maciek, that's because you never went through the hell of ESBs and the old school SOA. That's why people run screaming. That's why you call it microservices. Don't tell them it's SOA. It's microservices.
It's all marketing.
Yeah, I think a big part of that is really identifying where your scaling issues are. So we've had a lot of stuff that we didn't even necessarily break it out into a separate code base where you could even arguably call it a microservice, but just by putting certain portions of functionality on different clusters where it could scale better, that solved huge issues. Like our TLEG processors were constantly running out of memory, and it would kill other things because they were taking down rescue workers. So part of it's really just, it is very like, I forgot the term. It's very case by case, right? Of like, figure out what's your biggest pain point and what helps you the fastest with the easiest, the least amount of work.
Yeah, we're also pretty lucky in that we have a lot of like asynchronous queue kind of processes. So that helps things a lot as well. So we got some over there. Oh, sorry.
Yeah, I have a question about just handling your infrastructure. So you already mentioned about AWS accounts. So I was wondering if you guys managing multiple AWS accounts, like you're split up per environment and maybe per some particular product line or whatever. And if so, I was wondering if you're using any third-party tools for managing that, or you have some like tools built in-house, or maybe like rely on the AWS landing zone, or what do you use for that?
So we try and keep it a few accounts. Like right now, like we said, we've got that legacy monolith account, which is the first one, and that has a lot of the hand jam and stuff and like that. And then we have like a staging account, and we have one for like data science, I think, to do their stuff in. And we also have like a nice shiny new production Kubernetes kind of account. So we try and keep them down more limited, and we use AWS Vault as an ability to change roles, so we can switch between accounts and do that way. But we don't use anything other than that. And we don't go to the like, oh, each department has its own kind of AWS account. So.
I've got a bit of a follow-up from the guy in the blue back in the back. So not how did you do it, but how completely did you do it? So if your monolith is 100%, how much of that is actually a web service, and how long did that take you?
We're not anywhere close to done. And that's a question that kind of remains to be seen. We're still very much in the midst of doing the strangler pattern. We're still relying on a lot of shimming in and out of the old monolithic infrastructure. We have quite a few areas of the monolith identified as candidates for microservice sizing, whatever you want to call it. But we'll kind of see, right? Like we'll see as we take more and more parts of the code out of the monolith that inherently also takes off the load, and just kind of see how things evolve. And at some point you're then coming to another balance point of, okay, do I want to keep ripping more stuff out of the monolith just for a microservices architecture's sake, and thereby making that design and system a little bit more complex and a little bit harder to reason about, versus just keeping in there and like it's still fine. So it's very much an open question, which I realize doesn't really answer your question, but we're just kind of in the process of it.
So like, I'd say the biggest part that we've actually built as an independent service is what we call content service. And so the APIs from the monolith that served the app for like offers and bonuses, so the coupons, if you're familiar with Ibotta, like what we serve to users, that's been completely broken out into a separate service. So it goes through an Elasticsearch API as opposed to a Rails API, which, like Matt mentioned, is a much more flexible sort of, it's a GraphQL interface. But that's probably the most significant part that we've actually like built on a completely separate service, on a completely separate code base, on a completely separate data structure.
And we're also building a lot of new functionality as well, and the majority of that is being written in those services. So it's more of a case of don't write new stuff in the monolith unless it really makes sense to do it. Like the standard is to like write it as a new service. So that's how we're trying to avoid like it still expanding all the time. But yeah, other than that, it's a case of like, what's the benefit for us breaking it out?
Yeah, and I think one of the biggest conflicts we run into, and probably most organizations run into when they're trying to do this, of like breaking apart their code base into microservices, is like, okay, if I have a feature request, I could add that feature in the monolith in like 2 days. Or I could build a new microservice to service that feature in like 2 weeks. Okay, so what's important? Building it in like a more manageable, more maintainable, more like future-driven fashion, or doing it fast? Because sometimes the answer is doing it fast. Like I've been leading a squad where our whole entire focus is like, we have to have this done by the end of Q2. And that meant building a lot of functionality into the monolith that could have been a microservice, but we just didn't have the time to do that.
How are you, or are you ensuring that you don't end up with what I call a monoservice? Right, so on that topic, I could build a microservice for something, or I could add it to the monolith. You build the microservice, and then 2 months down the road, you add more to it, and you add more to it, and now it's a monoservice. It's its own mini monolith. Are you doing anything to try and stay away from that, or is it just organic?
So I'd say like the content service has a lot going on, but it's still like a bounded context. Right? The whole context of that service is I serve content to the app. So if you're trying to add something there that's like, I want to maintain the budget of things, it's like, okay, it's a completely new thing that doesn't even make sense. So I think part of it's having that bounded context of the service where it's very clear whether or not something falls in that domain or doesn't. But you're right, there's still a conflict of like, for example, we built this service in the monolith because it was faster as our system is doing things, reacting to events, and basically generating billables of what we can actually bill to a client. We wanted to do that as a microservice, and that was the original intent, but we didn't have time. And so our plan is to build that as a microservice. There's sort of a secondary component of budgets, which is when is a budget expired and I should stop serving that content to shoppers? Well, these are both budget related concerns, but should they be in the same service or not? And I think within Ibotta, the mentality actually leans more so the other way of what you're suggesting, where like people went super tiny microservices. And to some degree that's valuable, but I also don't want to have to deploy 500 services every day, right? So there's definitely a balance of like, you don't want them too small, you don't want them too big. And there probably isn't a good prescription for what the answer is. Yeah, it's a gut check. It's, and I think going back to like the bounded context is probably the strongest indicator of like, well, if it's a budget related thing, okay, well, we could talk about whether or not these two budget related things should be in the same service. But if it's like, apples and oranges, and it's obviously apples and oranges, then it just obviously doesn't go together. So it's sort of a case by case.
Yeah, and it's even more than a gut check. It's a learning along the way. It's kind of funny that you should mention monoservices, because we are starting to feel that content service is becoming a monoservice, and we're like, hey, this is our first microservice. Let's bust it up into microservices. There is no right answer. It's something you just kind of have to learn along the way. And yeah, sometimes your boundaries will be inherently clear. Sometimes they kind of evolve over time. And you just have to take the learnings as they come. Sometimes it's okay for something to grow bigger, because it even starts to become the question like, what does bigger mean, right? Like, is it becoming the logic is now becoming squirrely? That's a pretty good indicator of, hey, maybe we went a little bit too far with this, and we need to think about how to take it back. But if it's just a case of, great, we have this one microservice and there's 100 pods of it out there, that's not necessarily a bad thing. That means it's working well, right? Like you've managed to isolate it in such a way that it's easy to kind of scale around. But yeah, it's very much a gut check, a learning along the way, and just figuring it out as the system evolves.
And I think that's part of it's like, as you're building a microservice, attempting to componentize even your microservice. So if you decide, hey, I want to split this functionality out, that it's actually easy to rip the code out. So like we've been doing a lot of like Spring Boot plus Camel services. And like I recently refactored a Camel route where I broke it out into 2 separate routes, where one was very domain specific and one was actually very generic. So technically that generic one could live in a completely generic service where the domain specific one feeds over to it. And so I think part of it's just like building your code to be modular, which I think is one of the things that Ruby on Rails doesn't scale well with. It's not easy to rip things out of Ruby on Rails because it lends itself to be very spaghetti-like, not ravioli.
Yeah, and I think you're always going to be refactoring. You always I think you're better off, like, you don't want to get into that analysis paralysis where you're scared to do it because you haven't got the perfect plan. You're never going to have that. You're better off starting and trying something and then looking at it and going, yeah, that was a bad idea. We should have done this instead. You've learned, you can then get gain from that, rather than sort of like try and do this perfect thing. And things change over time as well. The requirements for it change. You get new things that come in. And so maybe you did get a pretty good view of it at one point, and then like you had some rush of like, we've got to do this because we promised the customer we're going to be able to do that. So we put it in this service because that was the most quickest thing and the best thing to do at the time. But then after, you need to be able to go back and reconsider that and say, okay, like the technical debt and refactoring is a problem, whatever kind of system you use. But you definitely need to be able to do that. And you need to be able to say, look at our assumptions again now. Are they still valid? Should this service, should it still be a service? Is it like we built this thing and we thought it was going to be great and nobody ever calls it and it's sad on its own and like we're just going to kill it? We're going to take it out now because it's no use anymore. And then maybe other ones where they started off and they were going to do one little thing and then everybody thought that's the coolest idea ever. I'm going to call that service, and now it's like some huge thing and you need to start splitting it out. So there's no right answer. You just got to try it and go for it.
And maybe another thing you can think about too is like interface definitions. Like if I have to really think really hard about when I call a service, what it's going to do, it probably has too complex of side effects all in one call. And so and this kind of goes back to like the contract definitions with like gRPC or any other sort of contract definition framework. Of like, if these are very, very simple interfaces that do sort of simple focused tasks, as opposed to like, do the thing and like 20 different things happen on the back end. And that's the only reason why I call that's a good place to break it up. So if you can't easily reason about how an independent interface call is, like what that's going to do, that's probably a good indicator as well, that it's too bloated. All
right, I think we're going to wrap it up there so that we can let people go home. But if you still want to, hang around and talk, I'm sure some of us will at least be here for a while. One last plug, I wanted to say that there's a book by a guy called Sam Newman, and I can't remember, it's something microservices. It's got like the bee hive cluster kind of thing on the front of it. O'Reilly book. That's definitely worth a read.
Also, Ibotta is hiring.